Okay, guys, so quick lesson on the wave equation. C equals lambda times nu. Okay, so again, C is the speed of light, and that's a constant, 3.0 times 10 to the 8 meters per second. And then lambda is the wavelength, and we need wavelength to be in meters. And then nu is the frequency. It's kind of like a V with a little tail on the end of it. That's the frequency. And frequency is generally measured in cycles per second. We just say 1 per second, 1 cycle, 1 wave, whatever it happens to be, 1 per second. And that is the unit hertz. So you've probably heard of hertz before. And so that's hertz. So 1 per second is the same thing as a hertz. So an example problem might be this. I'll just give you the data. It'd be in a word problem. But something like, what's the frequency? So the frequency would be the question. If the wavelength is, we can go 3.85 times 10 to the, we'll go 10 to the negative ninth of a meter. And so what you can do here is you'll take the equation C equals lambda times nu. This is just an algebraic solution. We are solving for the frequency, which is actually the nu. I don't know why I put an F there. And so solve this out for nu. So rearrange. You're going to divide your lambda into both sides, and so we get nu equals the speed of light over lambda, and then you're just going to plug in. These are very simple, straightforward equations. Just want to give you an example before you came to class. 3.0 times 10 to the 8 meters per second, speed of light, divided by the wavelength, which is 3.8 times 10 to the negative ninth of a meter. And then punch that into your calculator. Let me do that real quick. And you get a numerical answer of 7.89 times 10 to the 16. Now, what's our unit? What you have here is you have a meter per second divided by a meter, which the meters will cancel, leaving you a 1 over a second. And a 1 over a second is the same thing as a hertz. So that's our frequency, 7.89 times 10 to the 16 hertz. So that's one example. I want to tell you about nanometers, because that's going to come into play as well. A nanometer. And so the prefix nano means 1 billionth, so it's 1 times 10 to the negative ninth of a meter. The reason why nanometers are important is because in our visible spectrum, our Roy G. Biv, we measure those in nanometers. Red waves are approximately 700 nanometers in length, in wavelength, and violet waves are about 400 nanometers in wavelength. And so if you had 700 nanometers, that's going to be 7 times 10 to the negative 7th of a meter. You're going to see that negative 7 a lot. If you see negative 7 meter, you move your decimal over 2 spots, you get negative 9, so that would be 700 nanometers. If you see 400 nanometers, you might see it as 4 times 10 to the negative 7th of a meter. Again, move that decimal over 2 spots, that negative 7 becomes negative 9, and that's the equivalent of 400 nanometers. And so if you, again, I just want to point this out. If you see some number times 10 to the negative 7 of a meter, what it's really looking at are nanometers. And the reason why nanometers are important is because that is what our visible spectrum is in. We see light of wavelengths, see if I can spell here, wavelengths in the 400 to 700 nanometer range. That's the visual range that we see in. And so I wanted to tell you about nanometers there. You can also have things like megahertz. Megahertz. Let me go to the next page. Megahertz. Well, mega means a million, so that would be 1,000,000 hertz, or 1,000,000 1 per second, because that's what a hertz is. Or you could just do 1 times 10 to the 6 cycles per second, or 1 times 10 to the 6 hertz. Okay, so you may see other units of hertz. Whenever you're plugging into your C equals lambda nu equation, this lambda needs to be meters, and this frequency needs to be simply hertz. So if you are given a problem with megahertz, you'll need to make a quick conversion to hertz. If you're given a problem with nanometers, like if you were given 400 nanometers, then you would need to convert to meters. And so I wanted to make you aware of what a nanometer is. A nanometer is a billionth of a meter. 1 times 10 to the negative 9 meters is a nanometer. Okay, so we'll start working some of these problems in class, and we'll get into them. See you later.